Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics, Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class to carry on my regular activities. Here, I also hope all of you are passing your good moments with your families by the mercy of Almighty. Right. Dear students, today we are going to discuss some important topic from our 7th chapter of physics second paper, that is the chapter of physical optics. Okay, and our topics are wave theory of light, electromagnetic wave theory and its properties, and Poynting vector. Dear students, already we have learned there are 4 theories regarding light so far, and the theories are Newton's corpuscular theory, Huygens wave theory of light, Maxwell's electromagnetic theory of light, and finally Einstein quantum theory of light. Among the 4 theories, today we will discuss on 2 theories, and they are Huygens wave theory of light and Maxwell electromagnetic theory of light. Student, now we are going to discuss about Huygens wave theory of light. Contemporary to Sir Isaac Newton, famous Dutch scientist, Huygens first put forwarded this theory. Later on, Young's, Fresnel and other famous scientists also well established this theory. And according to this theory, light traveling through a hypothetical medium named ether from one place to another place, when reaches to our eyes, it creates a feeling of vision, right? Some optical phenomena like reflection of light, refraction of light, diffraction of light, interference of light can be explained with the wave theory of light. But some other phenomena of light like polarization of light, photoelectric effect of light cannot be explained with this theory of light, right? So this is the shortcomings of this theory. Later on, by the experiment of Michelson-Morley, it was established that there is no existence of ether medium in the nature. Okay, dear students, now we are going to discuss on Maxwell electromagnetic theory. The word electromagnetic, from this word we can realize that this is related to two fields, that is electric field and magnetic field. So Maxwell electromagnetic theory deals with phenomena which is related with electric field and magnetic field at a time. Okay, actually we have already learned that a stationary charge or a charge body at rest can create an electric field which does not changes with time, but a charge moving with uniform speed, a charge moving with uniform speed can create an electric field and a magnetic field at the same time. This field also does not changes with time. On the other hand, a charge moving with acceleration, can create variable electric field and variable magnetic field which changes with time periodically. Here the electric field and the magnetic field always remain perpendicular to each other. Dear students, actually in 1831, Faraday first discovered that a variable magnetic field can create a variable electric current. Again, in 1864, Maxwell proposed that a variable electric current can produce a variable magnetic field. Okay, actually among the two fields, that is between variable magnetic field and variable electric field, one is a consequent of other field. If a variable magnetic field is created, as a result a variable electric field also created. On the other hand, if a variable electric field is created, then it will create a variable magnetic field. Okay, so now we can see a figure of electromagnetic wave. Dear students, if we consider 3 mutually perpendicular axes, x axis, y axis and z axis. Okay, so we consider two transverse wave. One is represented by the green color or green shape, which is vibrating in the xz plane, that is in the vertical plane. In the vertical plane, the green shape wave is represented, and in the xy plane, that is horizontal plane, a red shape wave is vibrating in the horizontal plane. If we consider the green shape is electric field and red shape is a magnetic field, so this represents a electromagnetic wave which carries at the same time an electric field and a variable electric field and a variable magnetic field, which changes periodically with time, right? Here the electric field E at any moment can be represented as E naught into sine twice pi by lambda into Ct minus x, and the magnetic field, which is denoted by B, is equal to B naught sine twice pi by lambda Ct minus x. Okay, here E is the electric field at any moment, and E naught is the maximum value of the electric field, which is also known as amplitude of the field. Sine twice pi lambda is the wavelength, c is the speed or velocity of this electromagnetic wave, t is the time, and x is the distance from the source at which the electric intensity is E is measured. Similarly, B is the magnetic field at any moment. B naught is the maximum value of the magnetic field, which is also known as the amplitude of the magnetic field, twice pi by lambda is the wavelength of the wave, c is the speed of the electromagnetic wave, and similarly x is the distance, right? Dear student, now we can see a video to realize this phenomena more clearly.
In the modern world, we humans are completely surrounded by electromagnetic radiation. Have you ever thought of the physics behind these traveling electromagnetic waves? The great scientist Heinrich Hertz was the first man to transmit and detect electromagnetic waves. In his famous experiment, a high-voltage current was applied to the two ends of two metal wires, which generated a spark in the gap between them. This spark resulted in the radiation of electromagnetic waves. Those electromagnetic waves traveled through the air and created a spark in a metal coil located over a meter away. If you had placed an LED in that gap, the bulb would have glowed. This was a clear case of electromagnetic wave propagation and detection. In the field of antenna technology, the oscillating electric dipole. The interesting fact about this simple oscillating dipole is that it produces electromagnetic radiation in a perfectly sinusoidal manner. Let's see how it is achieved. Before getting into the electromagnetics, let's understand how velocity and acceleration vary in this simple case. It is clear that at both ends the velocities should be zero, and in the middle the velocity should be at the maximum. This means that this is a case of continuous acceleration and deceleration. The electric field pattern is drawn here when the chargers are far apart and when the velocity is zero. In order to have a better understanding, let's examine one of the electric field lines. Let's observe the electric field line at t by 8. You can see that the electric field line is deformed. The reason for this deformation is simple. This time period is the region with the highest acceleration. As we saw earlier, accelerating or decelerating charges cause kinks in the electric field. In short, the old electric field does not get adjusted to the new field very well. This deformation is continuous since there is continuous acceleration in the charge. When two charges meet at the central point, the deformed line also meets there. After that, it detaches and radiates. This radiation travels at the speed of light. If you plot an electric field intensity variation with respect to length, you can see that the radiation we have produced is perfectly sinusoidal in nature. Please note that this varying electric field will automatically generate a varying magnetic field perpendicular to it. Now, let's have a look at how this applies to an antenna. A time-varying voltage is applied to the metal wire as shown. Due to the effect of the voltage, the electrons will be displaced from right to left and create positive and negative charges. With a continuous variation of voltage, the positive and negative charges will shuttle back and forth in the wire. This simple arrangement is known as a dipole antenna. The dipole antenna produces the same radiation as we saw in the previous section. In this case, the antenna works as a transmitter. The frequency of the transmitted signal will be the same as the frequency of the applied voltage signal. The same antenna can act as a receiver if the operation of the antenna is reversed. When propagating electromagnetic waves strike the antenna, the oscillating fields of waves create positive and negative charges at the ends of the antenna. The varying charge accumulation means a varying voltage signal is produced at the center of the antenna. This voltage signal is the output when the antenna works as a receiver. We can note here that for perfect transmission or reception, the length of the antenna should be half of the wavelength. This is the first antenna design criterion for proper reception or transmission. The second most important design criterion is a term called impedance matching. Perfect impedance matching will make.
Again, Maxwell shows that the speed of the electromagnetic wave, which is denoted by C is equal to E divided by B or E naught divided by B naught. The speed of the electromagnetic wave can be obtained by the ratio of E and B or E naught by B naught. We also showed that C, speed of electromagnetic wave, is equal to 1 by square root of mu naught epsilon naught, right? Here mu naught and epsilon are two constant. Here mu naught is a constant which is known as permeability of vacuum, and its value is 4 pi into 10 to the power minus 7 Newton per ampere square, and epsilon naught is permittivity of vacuum, and its value is 8.854 into 10 to the power minus 2 C2 Newton inverse 1 meter inverse 2. So this is the two value of the two constant. So after using these two value in this equation, Maxwell found that the value of C is 3 into 10 to the power 8 meter per second. Dear student, the value of C obtained from this expression using these two value, like this value, the value is C is exactly the value of speed of light. So from this result or from this conclusion, Maxwell said that light is nothing but an electromagnetic wave. Okay, so we can say that electromagnetic wave travel with the speed of 3 into 10 to the power 8 meter per second, or with the speed of light, right? Dear student, finally we can see the definition of electromagnetic wave as the simultaneous periodic variation of mutually perpendicular electric field and magnetic field intensities which passes through vacuum at a speed of 3 into 10 to the power 8 meter per second is known as electromagnetic wave, right? Now we see some important properties of electromagnetic wave. Dear student, these are the main properties of electromagnetic wave, and these are among them. The first one is electromagnetic wave is produced due to the periodic change of electric field E and magnetic field B, right? Electric field E and magnetic field B. The direction of transmission of electromagnetic wave is perpendicular to both E and B. Third property, for the propagation of electromagnetic wave no medium is needed, that is electromagnetic wave can travel through vacuum. And in fourth, the intensity of radiation or electromagnetic radiation is inversely proportional to the square of distance, that is E is directly proportional to 1 by r square. Here is the intensity, here is the intensity of electromagnetic wave, and r is the distance of the point at which the intensity is measured. 5. For all electromagnetic wave, the relation between the speed of electromagnetic wave c, the wavelength lambda, and frequency f is c is equal to f lambda. Already many of you have know it. And lastly, the speed of electromagnetic wave is 3 into 10 to the power 8, which is exactly equal to the speed of light. These are the properties of electromagnetic wave, right? Now we are going to see what is Poynting vector. Dear students, like all type of wave, electromagnetic wave can transfer energy. So British scientist Henry Poynting showed that the energy transferred by a electromagnetic wave through unit area of a plane placed at the perpendicular direction to the propagation of electromagnetic wave in unit time is denoted by 1 by mu naught into E cross B. Here E is the electric field and B is the magnetic field. So this indicates a vector. Here E cross B, that is the cross product of two vectors. We know the cross product of two vectors is also a vector. Its magnitude is equal to the energy which passes or which transferred by electromagnetic wave in unit area, but through unit area of a plane which is perpendicular to the propagation of electromagnetic wave in unit time, right? So this vector is known as Poynting vector. So Poynting vector is denoted by S. Poynting vector is denoted by S. So S is equal to 1 by mu naught into E cross B. This is Poynting vector, right? It's a simple concept, and the unit of Poynting vector is watt per meter square, right, dear student? So I hope you got the topic we discussed in our class. So you have to read your book to make it clear. So thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.